Hi everyone. We are Blindside Vision. My name is Vin,
My name is Sahar.
My name is Jonathan.
And I'm Wathik.
and we are here today to introduce to you guys our senior design project, Blind Spot Detection System.
So let's start by going into the theory of this project. So currently there are two companies that are currently that have released patents for making blind spot detection systems for motorcycles, and that's going to be Honda and Continental. So what we want with our project is to have a modular blind spot detection system which easily installs on most motorcycles. And we want to notify users via LED notifications which will be installed in the mirror or in the helmet.
So the overall objective of this project is to create a blind spot detection system that is capable of detecting moving vehicles within its user's blind spot, and also provide feedback to assist the bikers with assessing their surroundings. Our main objectives we wanted to accomplish is to make the system modular and detachable, also user-friendly, which means it will have easy installment, be mostly universal and attached to most motorcycles, affordable, and in our case under $75, have a battery life of at least 4 days, and in our case it's 15 days, and also provide visible notification to the user.
And for our design alternatives, we came up with three main designs. Design 1 and 3 are similar in terms of power supply. And the power supply for the first and third one is the motorcycle battery, but the output is different. The output in the first one is the haptic feedback, while in the third one is in helmet audio. And the first one we are using the ultrasonic speed sensors, while on the third one we are using the camera and image processing. But we came with the best that's going to be the best for us. It's design alternative 2. We are using 9-volt battery as power supply and LiDAR as sensor, and the output is going to be LEDs on helmet in both sides. And the main design factors are, we came up with four main factors. Cost effective, it shouldn't be more than $100. It's very easy to manufacture. Also interchangeable in case the motorcyclists have more than one motorcycle. It's going to be easy for the person to move it from one to another. Also, it's very maintainable to manage.
So our team was able to fulfill our main objectives for our project. We did complete the design of the bracket in SolidWorks software, giving us a physical of our system. We also did complete hardware coding and lab testing, which does validate that the concept of our project is valid. However, because of recent circumstances, there were some shortcomings. We were unable to 3D print the bracket design, and we were also unable to physically meet after a certain point, therefore limiting the amount of real-world testing we could do. Finally, because we wanted more accurate data, we did switch sensor choice to LiDAR, which put us over our $75 budget.
So we're going to be looking at project innovations. Again, as mentioned, currently Honda and Continental have released patents for blind spot detection systems. However, these systems are much more technical and mechanical due to the fact that they use auto-aligning for motorcycle leaning while taking turns. However, that is a feature that is mostly involved for racing, since typical riders will not be leaning that hard. Also, these systems will only be available on newer motorcycles, and this is where blind spot vision system excels. So our system is going to be less technical and less mechanical. And the system is going to be available for most motorcycles, so it will be easy to install on older ones as well. Also, as mentioned, our modular design allows us to install on more than one motorcycle. So if an owner has multiple motorcycles, it is easy to install from one to another.
Since we all becoming engineering students, we try to incorporate as many as possible IEEE standards into our project, and this is such a standard.
So here we have a rough demo of what our project is going to be like and what it's going to run like. So we will continue playing the video here.
Hello everyone, my name is Jonathan Hanches. We got Watek filming over there, and this is half of the team of Blindside Vision. So let's get right into the video. We want to introduce you to our project. So what is our project? It's a blind spot detection system. So basically, what we're doing is we're going to be making a small bracket that's going to be holding most of the hardware. And it's going to be placed right here, right under this license plate, and right between this bracket holding the license plate. So the thickness about this bracket is about 1 inch, and it is a 4x7, which is the official size of the license plate. So again, our bracket is going to be holding the batteries, the hardware. A lot of the hardware is going to be in here. But the two things that are doing the blind spot detections are going to be our sensors. So we're going to have one sensor on the right and one sensor on the left. So these sensors are actually LiDAR sensors. We originally wanted to do ultrasonic, but we realized that's going to be an issue for us since the motorcycles and typically cars move at higher rates of speed. So we came to the conclusion that LiDAR is probably what we want to use. So LiDAR essentially sends a beam of light and it bounces right back, and it calculates the amount of time that it took for that light to travel, and it will make that, it will work out the math, and from there we will derive our distance. So that's the most, that is mostly what our bracket is doing down here. That's most functionality that it's going to have right now. So we're going to move on to the helmet. So the helmet is going to be connected to the bracket down here via Bluetooth, and they're going to communicate one to another. So if we open the visor, we have two spots here that we're going to stick LEDs, one on the right side and one on the left side. So when this bracket detects something in its left blind spot, it will notify the user that there is someone in the left blind spot. And same with vice versa. If there's someone on the right side, it will notify the user that there is someone on the right side. And what we're going to do is we're planning on mounting, excuse the paper, we're planning on mounting the hardware because it's very minimal hardware required here. We just need a Bluetooth receiver and a very small Arduino, which we're already using. We're going to be mounting them right here with Velcro, and it's a very small box, and it's going to be running wires through the helmet, which we do have space for because there is padding, and you're given a lot of room to run wires through here. So we're going to run again the wires to the top here on the left and the right side, and it's going to notify us of what side there are detections on. So in conclusion, that's what we mostly have here. The thing is, we can't have anything official yet because we are not completely done with our project yet. We are still working on putting everything together and finalizing it. But you guys will see in our next video that we have a video of us testing it. So you guys will be able to see how our sensors work and how the LEDs work. So we're very sorry for the inconvenience not being able to provide it, but we are doing our best here given the cases. But again, we want to thank you for your time. Have a great one, and thank you for listening.
So in this video here, which I'll hand to Wojtek to narrate, we will be showing some testing that we've been doing with our project.
So as we see here, this is our entire system working. The box here represents a car approaching the motorcycle, and the blinking LEDs are going to be fixed in both sides of the helmet. So as long as it's green, it's safe, you can go, and now it's red. That means it's dangerous. Don't take the risk and go to the other lane.
After all, for our conclusion, we are really happy with our project and what we come up with so far. However, with recent event that happening to our country, we are unable to really go through all of our process and have the final product. But thank you all for your time and listening, and stay healthy.
Thank you.
Thank you. Thank you.